Okay, so let's look at this example, which is exercise 8.19, page 99. So we have this one. I hope you can see it clearly. Okay. What is it? No, focus. Okay. So this one. Okay, so exercise 8.19, page 99. So the question said, replace the rigid body support the loading shown, determine an equivalent force couple system at A. Okay, so the question asks you to replace these two forces with the given couple with only a force couple system at point at point A. Okay, so remember our step. Moment A, Rx, Ry, theta. Okay, so moment Rx, Ry, and then calculate R, calculate the direction, and you finish for that one. Okay, so we start with the first one, moment at point A. Okay, because it involves several moments and couples, so we should choose our reference point, which is to clockwise as a positive direction. So first we'll put the moment created by couple, which is these two. Okay, this one is positive, so 6 kilonewton meter. This one counterclockwise, negative, minus 9. Okay, so this is the moment created by these two couple. Okay, and then we go to the moment created by forces. We have these two forces, so I will eliminate this force and replace by their component, which is we resolve one is here and the other one is here. This is 60, so this is cos 60, this is sin 60. Here we resolve into two components also. This is cos 30, this is sin 30. Okay, so we have these two 1, 2, 3, 4 forces now, because we resolve these two 5 and 8 kilonewton into component X and Y direction. So we took one by one. Pin at A pushing this direction, so the whole component will be pushed. We go to counterclockwise. So negative, this one 5 cos 60. Okay, negative this one. Not because the direction of force which is negative, because the moment created by this force is counterclockwise. We say clockwise as positive, so this one is negative. So put it pin here, push the direction counterclockwise. The distance, make a line here and the second line at point A, so you see that the distance is 4 meter. Okay, this one, put a pin here, pull this direction, so we turn clockwise. So plus 5 sin 60. Distance, you make the first line at the line of action of force, second line parallel to this one, but go through the A, so your distance is here 2. Okay, so finish for these two. We have this one, put a pin here, pull this direction, so it will turn clockwise. So plus 8 cos 30. Okay, make a line here and a second line on this point, so your distance here is 2. And this one, you pull this direction downward, so it will also turn clockwise. 8 sin 30. Make a line on this force and the second line parallel to this one, going through A, so you have 2 as a D, so you have also 2 here. Okay, so this one will be equal to something. Calculate that one. You will have negative 5 cos 60 and then times 4 equal to, plus we have 5 sin 60, distance 2, okay, plus 8 cos 30 distance 2, okay, plus again 8 sine 30 distance 2 equal to, okay. So now we have, this is already negative, I put a negative at the beginning, so plus 6 equal to minus 9 equal to, so you should have here somewhere 17.52 Newton meter. Okay, so 17.52 Newton meter, it is positive, meaning that same direction as our positive here. Okay, so we have the moment. So I'll write here, moment A equal to 17.52 Newton meter clockwise. Okay, so we finish for the first one, sigma moment. So we go to the second step, Rx, Ry, and theta, R theta. Choose this direction is positive, sigma, no, directly Rx equal to, so Rx, we have these two. You see the first one, this one is negative, because negative opposite from this one, this is to the left, this is to the right, so we have negative 5 cos 60. So of course here, before I forgot, everything is in kilonewton, so here should be in kilonewton. Meter. 5 cos 60, this one is to the right, so plus 8 cos 30, you should have here, minus 5 cos 60 equal to plus 8 cos 30 equal to 4.43 kilonewton, positive, so this direction, upward positive, at y equal to, this one is downward, so 5, negative 5, sine 60, this other one is also downwards, and negative 8, sine 30, so negative something, minus 5 sine 60 minus 8 sine 30, 8.33 kilonewton, so it is actually 8.33 kilonewton going downward. Okay, so we have Rx to the right, so plus, this is your start point, this is Rx plus Ry, which is at the end of Rx, going downward here, so we have Ry, so this is end point, our R is from start to end point, so this is your R, this is your theta. Okay, so from here you have the R equal to square root of 4.43 squared plus 8.33 squared, you have the R. .43 squared plus 8.33 squared, square root of everything, you have 9.43 kilonewton. Theta is equal to tangent minus 1, y divided by x, so 8.33 divided by 4.43 equal to tangent minus 1, 62 degree. Okay, so you have here R equal to 9.43 kilonewton, 62 degree to downward. Okay, so your final answer, as said, you should be in redraw this one, or you can redraw, or only draw the part of it. So I will erase this one. Part stem. So this is your component. Okay, so you want this point actually, which is point A. So you draw that one. The final answer is, put the R which is 9 downward. So this is your R 9.43 kilonewton, 62 degree. Moment, which is clockwise 70.52. So you put here moment 70.52 kilonewton. Okay, so this is your final answer. Okay, redraw that point A. If the component is not complicated, you just redraw everything. Okay, and replace all the forces and moment into only one force and one moment, which is what we already calculate. Okay, so that's it. Your step is first calculate the moment at point asking, at the point that the question asks, and then Rx, Ry, R, and theta. So this is the thing that you already done 100 times, so you should have no problem doing that one. Rx, Ry, calculate the R and the theta, and then replace everything to only one point, redraw that point, and put your answer. Okay, so that's it for this chapter. Simple one, okay, because it involves combination of two chapters that we have already mastered, which is moment and also sum of force, which is R. Okay, in 2 dimensions. Okay, so that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. See you later.